I think for lack of, well, I guess not for lack of anything, I think I'm going to do one practice run without telling anybody about this and see how it goes. So I'm writing a text editor. I'm writing it in for my Mac. It's just for me, and I figured some other people might be interested in this too. And so right now, I have a little document-based application set up, and the plan is to just try getting something showing up on the screen. I have an empty window now. I'd like to get some text showing up on the screen. And this is probably a mistake, but I'm using this new attributed string rather than NS attributed string. And the bigger mistake is probably not using TextKit 2 or TextKit. I'm using core core text directly, that's probably not a huge problem. But I'm trying to duplicate the TextKit 2 API because I know it well, and I think that's probably overkill. But we're going to see anyway. So in the meantime, I'm debugging something. So let's figure out what's going on. This enumerate text elements. So this is so basically this function starts at a location in the document. In this case, it's the beginning of the document, and calls this calls block for each paragraph, or for each text element, which in this case is a line or a paragraph, something that ends in a new line. And so string index is out of bounds. We're going to find out. We're going to find out why. So can we do this? Yes. If we do, but this is what caused the issue. Yeah. So my guess is because text location is equal to the start index of the string, but we can't actually slice this way. We can't actually slice in this direction, so I think we're going to have to special case it. All right, so what's that going to look like? We're going to say is var I equals text location, and we'll say if I is not equal to s.start index, then we'll do this thing where we move back. And in fact, what we'll do is this is going to be the element start. We'll just call it the start. Let start equal start characters sub text up to text location. So what we're doing is we're searching for either the last new line. And you know what? Then we're going to have to increase it by one also, which is the thing that I'm not doing here. So we'll take care of it. We're searching for the beginning of the text element. So that's the character after the new line or the start index. So it might be the start index or it might be the character after the new line. And so this is the last index of a new line. And if we don't find this, there's nothing for us to do because I is already, oh no, actually, yeah, if we don't find this, we want to move back to the start of the document. Okay, right, that's what we're doing here. This is not actually necessarily start index. It was probably a simpler way to do this. Let's do it this way. So just do var I, and if text location is not equal to start index, to it, and otherwise I is just going to be, after this say, is going to be attributed string dot index. I'll say I equals s dot start index, which is really just the same as Maybe what I was doing before was going to be right. I'm not sure. Let's do this, right? So here we say I equals s dot characters. So we're going to go backwards to the last index of a new line. We'll say that's called line end. And then what we have to say is var if var line end. Then we can do line end equals, so this is, if we found the end of the line, that means we found the new line. We have to go to the next character. So s dot after index after character, and we give it line end. And you know what? Yeah, maybe that's good. So we've moved line end up by one, maybe. And then assuming we have, there has to be a better way to do this, and I also probably have to write some tests. And then what we have to do is we'll just say I is equal to line end for the start index. All right, so that goes away. Let's see what happens when we run this again. Oh, yeah, that's not going to work because it's shadowing. There has to be a better way to do this. Let's try it another way. So we say I is equal to the text location. And say if I is not equal to s dot start index, then we want to move backwards. All right, so then we're going to say line end equal and it's just going to be this again. So the problem is, here's what we have to do. So we say if let line end is equal to this, then I is equal to line end plus, or no, s dot after character, index after character of line end, which gets us to the line start. Otherwise, I is just going to be s dot start index because we want to go back to the line. I think this might work, which would be pretty cool. Technically, we don't have to set this, so maybe we do it like this. And then we say if text location is not equal to start index. I think this might be a little clearer. Oh no, because we need an else here, which is to say else. It's looking like it really looks like we can collapse this, right? This just gets us back to where I was before. Say, okay, so we're saying here, if the text location is not the start index, we find the end of the previous line, which might not be there because we may be on the first line. We do find the end of the previous line. We're going to start at the beginning of the next line, so one character after that. And otherwise, either if we were at start index or we couldn't find the previous new line, just go to the start index. Okay, maybe this works. Let's find out. No. That's a new one. All right, what do we got? Right. Um, all right, so I guess you can't go before they don't enjoy all of Swift's string indexing stuff. So I guess we can't do that. We'll just have to find another way, right? So what we can do instead is we can say if the difference between, if n index minus I is one, uh, or rather, if n index minus I is greater than one, we can keep going, right? And so this is s dot offset, maybe, yeah, index. And so we do offset by characters. Okay, so uh, we're going to start at uh, s dot. Oh no, it's not offset by characters because we want to subtract two indices. Let's try it again. Um, and this is the place where I think I'll just ask ChatGPT. So the question is, um, two attributed string dot indexes distance from two method. All right, let's see. Did we have that distance? No. Oh, maybe s dot characters dot distance. Yeah, look at that. Okay, so the distance from I to s dot end index should give us a distance in integer. Okay. From I to end index. And so if this is less than one, I think that might give us what we want. And what do we have here? Oh, needed last. Oh, no. Right. So I can't just add last back because that gave me an error. You know what we can do? Here's a better way. We can get last by going from the first index rather than the last index. Um, so we can say the last, right? We're not even using that here. Oversight. Okay, so what do we need to do? Index offset by characters. And we're going to start at the start index. We're going to offset it by that's dot count. Ooh, the number count of characters. Interesting. Cool. Maybe this will work. Probably not. Oh, look at that. Look at that. Okay, so it means we are now iterating over successfully all of the text elements. I don't even. Ooh, this is another interesting thing. Will layout, did layout. Okay, so we're not actually printing any of the text elements. So let's go somewhere and print the number of text elements. Ah, we are. We're printing them inside this enumerate layout fragment. Okay, so it looks like we're laying out a few times, but I'm not. There is no text, and this is unsurprising because this is actually the case. This is what's true, which is where I instantiate the where I call scrollable text view to instantiate this. I'm passing in, well, the document has no storage. Okay, so we're going to, you know what we're going to do? Right, this is what we're going to do. We have to go to the to document, and rather than loading the contents of the file of this, actually, is this even called? This may not be called because it's a blank file. It's not called. All right, so we just have to do this. This is a good place to do that. And look at that, we get two text elements, and then we get an index out of bounds. And this makes sense. We were expecting to find three text elements. And instead, each for one line, foo, bar, and baz. And instead, we found two and an index out of bounds. This is progress. Feeling good about this. Let's figure out what's going on. This is another very annoying thing is like, well, how do you interpret this character index? Who knows? You can't really. So we just have to do some printing like P. So let's find out where next and end are, right? If we do S dot index from the start, or yeah, no, it's X dot characters dot difference. Was that it? Difference. Oh, I don't even remember. No. Well, let's see. ChatGPT told us distance from two. That's what I thought it was. Distance. Oh, there it is. I don't know why I didn't think that was right. So S dot start index, and then we'll go to next. Oh, that just doesn't look right starting there, right? So I is 8. So let's see what's the 8th character into, I think that was the document. Yeah, 8th character into this. 1, 2, 3, 4, 5, 6, 7, 8. Is that right? Maybe it's 0, 1, 2, 3, 4, 5. Oh, no, I gotta count the new lines. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that makes sense. So I is at 8. So we get next because we want to go. What are we doing here? We are asking for the rest of the string following I. That's here, and then we find the first index of a new line. Of course, we can't then. Oh, can we not go to the last? Man, it's annoying because I think probably the problem is passing s dot index of the end thing, right? So if we do po s dot characters, or no, s dot index, and this is index after character, and we are going to start at last. And that's where we get the problem. Okay, so let's look at what last is. Look back at the distance. Start index to last is 11. Start index to end index is also 11. So last is end index, but that wasn't my intent. My intent was to have last be one less than end index, because end index is beyond the end of the string, and start index is end index is beyond the end of the string, and we want last to be the last character in the string. So let's do subtract 1. Is this no? Oh, right, because where we want to end up with is one character after the last character, or one character after the first index of the new line, because the new line we want to treat as being on the previous line. So look at that. 1, 2, 3 text elements, each representing one paragraph or line on the, of the input. Cool. That's pretty neat. Let's just check ourselves by doing a little bit to print the ranges in a nicer way. So we print. So what do we have? We have el.textrange.start, which is a text location. In this case, I can just. All right. Yeah. Here's what we can do. You can say the start equals el.textrange.start, which is this is attributed string. I'm sure I'm shooting myself in the foot by abstracting too early. I do this all the time, but whatever, we'll soldier on. So we have the start, the end, and then we're going to just get, right, because we don't have the ability to work with, what I'd like to do is I'd like to get these in just integers offset from the beginning of the string. We don't have, I don't want to, I guess we can just reach into the, to the storage, right? Storage as attributed string text storage. We'll also call this attributed string storage. Dot s dot index. Oh, I don't know why I wasn't using this before. If we take an index offset by characters, we can use s dot start index offset by start, and we'll say let s equals, and then let e equals the same thing, offset it by end, and then let's print s to e. Oh, and that's totally wrong. All right, what's the problem here? Oh, because let's do it like this. Just cast storage once, and then we can do storage.s.index, storage.start.index, offset by, and then this just becomes storage dot, and then storage dot, and then let's see what we got. Oh, of course, because it's not right. Yeah. Let's actually say string is equal to dot s, and then we can just do str dot characters dot difference from str dot start index by. Oh no, it's not from by. From to. What was I doing? I was doing it in the. Oh, it's gone. Oh, distance, not distance. That's why. Okay. Str dot start index to start, and it's going to do the same thing to end. All right. So does this seem right? So the first one goes from 0, 1, 2, 3, which is less than 4, and then 4, 5, 6, 7, which is less than 8, and 9, 10, 11. It's less than 11. 8, 9, 10, 11 is 3. All the others are 4. Yeah, that's correct. All right. We are in business. So let's commit this. What? Who knows what this is? Debug prints in there. Oh yes, let's go find that and get rid of it because I think I have a bunch of debug prints around here. I do. This is kind of messy code. We're just going to ignore it. I also have a breakpoint that wasn't getting tripped. It's interesting. Maybe that's a problem. Maybe it's not. Let's run it. Make sure we don't break anything. And the build failed. Oh, because I left that print in there. Cool. All right. So right now, what we have to do, I actually show the structure of this really quick. So I have a text view, and when the text view gets laid out, which I can show you here, you know what, I think now I can probably move layout back in to here, which is the better place for it to go anyway. There was a reason and a restriction that meant I couldn't do it earlier, and it's totally fine. Doesn't need explanation right now. The idea is whenever my text view gets laid out, which this gets called automatically and a bunch of times, like when the views are sized or something like that, I ask the layout manager to lay out the viewport. I am the layout manager's delegate, so it then asks me for the viewport bounds. That's the rectangle of where my viewport is looking in the document. And then it calls will layout, so I can do any setup. Then it calls this configure rendering surface for each layout fragment, which is, it's similar to a text element. They both represent the same amount of text, but a layout fragment represents the laid out version, so the typeset version, and the text element represents more like the text version. This is all just cribbed directly from TextKit 2, which is Apple's newer object-oriented text layout engine, which I was working with last summer, and it's pretty good, but it's kind of buggy, and I also kind of want to implement this myself anyway, just to learn. So anyway, it calls configure rendering surface for each layout fragment, so for each paragraph, and it calls it with the layout fragment. So I haven't done that yet. And then it calls did layout. And then in here, what I'm eventually going to do is implement, or rather allocate a core animation layer for each. I'll probably start with doing it for each layout fragment to get the paragraphs on the screen. So what this means is if the text wraps, one line can be, here's an example, right? Line 32 takes up 2 actual lines of text. And so this is the layout fragment, and then it'll be made up of 2 line fragments, this one and this one. And so eventually I'm gonna allocate a core animation layer for each line fragment, but to get started, I'm gonna allocate a core animation layer for each layout fragment. So 1 core animation layer rather than 2. Core animation layer is just a texture on the GPU that can get moved around. But the problem is we have to get this layout fragment. And the good news is this is where the fun stuff is going to be. So let's commit this. So this is text element enumeration. And so what we have to do in here is we have a text element. From the text element, we're going to make a layout fragment. And then we also have this layout fragment, and like we have these options. And this is going to basically ensures layout means we lay it out. So this is what a layout fragment is. And if it doesn't, for now, if it doesn't pass ensures layout, we're just gonna yield it, and it will have nothing. It won't be able to draw. Why can't I move this over here? I'd like to move this over here. Fragment. There we go. Okay, whatever. So let's actually look at what TextKit 2 does. Right, so you make a layout fragment with a text element, and the text range. Kind of interesting. I wonder why you have to pass in the text range because the text range is also on the text element. So if we look at NS text element, that is an element range. This is a range value that represents the range of elements. Oh, there's a lot of thunder right now. Our dog is probably going to be unhappy. I may have to step away for a bit. We'll see. So the element range is a range that represents a range value that represents the range of the element inside the document. And then this gets created, a range that defines the boundaries of the text for the new layout fragment. I guess this means it could be possible for the layout. Yes, and here, range in element. I see. So what they're doing here is here, a layout fragment can represent only a portion of the text element rather than the whole thing. And so this is called range in element. It's actually pretty confusing because they've called it range in element. Where it is, that's text element, range in element. It's relative to the document origin. So you think from this name, it would be relative to the element, but it's not. It's just our range within the element relative to the document origin. I think we're not going to bother with that. I think we can just construct a layout fragment directly from a text element only, and its range, the ranges will always cover each other. Oh boy, that thunder. All right, so we have our text range here, and what we're actually going to change this to is the text element. And do we have a, yeah, it must have a text element, yes, and it's weak, right? So this is the thing. It's nice, I might want to have these be, like, you can't have a weak reference to a struct, and text element is currently a struct. So, maybe these have to be classes. I don't know, let's try it this way. This is a complicated enough API that I'm just like cargo culting that it's not clear to me what the right thing to do is. So regardless, we're going to say we have a text element, which is a text element. And then we're going to, actually don't need to initialize. I think it'll just let us, we don't need to write initializer. So here's what we'll do. We will make a fragment equals a layout fragment, and we will make it from the element. And we'll just say if the options that contains ensures layout, and we will lay out the fragment. And then we will return the result of calling, I'm missing, right there. So we return the result of calling clock with the fragment. And this goes away, and now we have to mutating func layout. And here's where the fun begins. So this is where we have to learn how to use Cortex. So I believe what we need, well, we're going to need a frame setter, which is the thing, it typesets a frame of text. So a frame can have multiple lines. In Cortex, you can kind of go arbitrarily deep. You can go as arbitrarily deep as you want. We're going to have the goal is to get a list of CT lines, which are things that can actually draw themselves. And the frame setter will give us that. Just have to look at the thing. So we can create a frame setter with an attributed string, which is a CF attributed string. It then creates a typesetter. A typesetter lays out one line. So you could, for more customization, I think we can pass in a typesetter if we want, but we don't need to. And then there's these create frames. pass in the frame setter. All right. So let's start here. We need a CF attributed string. And by default, the text system doesn't typeset. What's an unreasonable amount of effort? Um, Unbounded layout. Oh, that's very interesting. Okay, so this can return null. So CF attributed string. I bet this is bridged to an NS attributed string. Blah, blah, blah. All right, so it's not clear yet how we, this is better. There we go. CF attributed string is toll-free bridge with its foundation counterpart. So what we need to do, the first thing we need to do is get an NS attributed string out of our attributed string with the with our range. And so we need a way to ask something, maybe the text element, give us an NS attributed string of yourself. So let's see if they are doing that here. So the element range content manager, so it has a reference to the content manager, which is the string storage. None of those matters. All right, so this doesn't have it directly on it. I kind of wonder if the content manager has, given a text range, give me an NS attributed string. That's where I think we're going to put it, unless there's a compelling reason not to. And it doesn't look like it. It could be in an NSText element provider, which is the parent protocol. Still no. Blah. Well, let's check the thing that implements that. So NX store. So this is NSText. What is it called? This is text storage. Text content storage is the thing that wraps it. There it is. So this will return an attributed string for the text element. Kind of makes me think, you'd think that eventually if they're using Cortex, it wouldn't just be NSText content storage, which is a concrete implementation of Content Manager, that would have to return this. That's interesting. Attributed string for, this is on text content storage. It's weird. Again, you'd expect to see it on NSText Content Manager, but it doesn't have it, and it also doesn't have it on NSText Layout Provider. Let's check the Layout Manager, NSText Layout Manager. No, that's replacing layout fragment. It seems like this would not be where they would put the reading of the attributed string, but and they don't, which is good because that kind of that'd be pretty weird. This is a thing that is mostly concerned with how to draw. Oh, you know what it is? I bet they put it. Yeah, there it is. Okay, so NSText paragraph is the sub. So, and I don't know why they put it in this concrete subclass of the text element, because it feels like this is something you'll need everywhere. You'll need to be able to ask a text element for its attributed string so you can pass it to Cortex, because Cortex works in attributed strings. And this even builds itself from attributed string an attributed string. So literally you just pass it attributed string. Okay. And this, none of this really makes sense, right? This one you make with a text content manager. text paragraph you make with an attributed string, how does it know what text content manager it has? Oh, none of this makes sense. Here's what I think we should do. I think text elements they should all have a function that gets us their attributed string, right? Var attributed string, which is an NS attributed string. And, for now we can return this. And then what we're going to need for the text element is it's going to have to be constructed with what I'm calling the text storage rather than text content manager, right? So this has to have it's a text range into the text storage, and that can read out an attributed string. So this is going to be a weak let text, weak var, I guess is the only thing we can do. Text storage, which is going to be a text storage. I think it's okay for that to be weak. And so therefore what we're going to have to do is guard let text storage. Otherwise, we can just return an empty string. If we have a text storage, then there should be a method always. And so we'll add this to the this is so interesting. I don't know how. It's like, okay, in the content storage, they're doing things like you can just make a text element out of an attributed string, regardless of whether that attributed string is in the storage. Whether it's actually within the text storage, which is the text content storage, which is a thing that maps or wraps NS text storage, I think. Concrete subclass provides attributed strings that you use in backing store. Right, this is a client of NS text storage using the NS text storage observing protocol. It conforms to this, which means we don't see this. There it is. Okay, that's why this has the text storage. All right, so that's what we're going to do. What we're going to do is we're going to say text storage dot, and we're going to have a way to get an attributed string from a range. Oh, come on. Text element map into an attributed string. All right, yeah, we can use this. We can do this API. So this is the on text storage. We're going to have another API that all text storage things have to implement, which is func attributed string for text element. This returns an NS attributed string. So now we can go to attributed string text storage, which I think we should name to attributed string storage. And it's telling us that it no longer conforms to the protocol for obvious reasons. So we can now make it conform to the protocol by implementing this thing. So what this does is it wraps an attributed string, or what the text the text storage does is wraps the attributed string, um, and we lost my train of thought for a second. It's wraps the attributed string. And so what we're going to do is we're going to pull the range out of the text element, get the attributed substring from the attributed string, and turn that into an NS attributed string. All right. So I think what we can just do is let substring equals s sub text element dot text range. The problem is this is just a text range, so we basically have to convert this into a text range of our the specific type of text range. It's kind of, it's like I don't totally know how much benefit we have from making this abstract in this way. We'll find out. But regardless, text storage distributed string for self. And then we want to return this. And now this is the only thing we have. So what we have to do is we have to we're just going to yell at it, make it work. So we say let start equals text element dot text range dot start as an attributed string index. Just maybe there will be a way to make this nicer, but it's, I tried doing it with generics and it got like so that we would know that this text range, like that you can only use text elements and text ranges with the appropriate type of text storage that they came from, but it didn't work. Or I think I don't understand generic, like kind of complicated generic programming nearly well enough yet. So we're just going to use these interfaces without associated types, protocols without associated types, and do these force casts. And type system's not getting us as much, and that's okay. So we now have this, and then we just do start exclude, the substring is start excluding the end, and then we return an S attributed string from the substring. And maybe this builds. What do we have here? Oh, you can't turn a substring argument into it. Oh, that's interesting. Okay, so let's look at this. NS attributed attributed substring. So this is no copy access to the relevant range, which is what I want. I only want to make one copy, but is there no way to create? Oh, wait a second. Maybe I just misread. Okay, you make it from, okay, so we can make it from this or this. Oh, no, that's an attributed string. None of these are great because they're not, let's see. No. Annoying. Well, that's ChatGPT just to make sure, but it looks like there's not a way to do that easily. Is there a way to convert an attributed substring to an NS attributed string with only a single copy? Let's see what it says. Yeah, I think it's going to show us the same thing, that we're going to, right, we take the substring. Oh, I think we should just turn it into an attributed string. I think that's a little nicer. because you get the copy either way. Let's also just look at attributed string protocol, see if it has anything for NS attributed, and it does not. Okay, well, we can look at this later. But what we basically have to do is take an attributed string of a substring and then turn it into an NS attributed string. To do, is there a way to do this with a single copy instead of two? Probably not. Okay, layout fragment. Layout fragment has no right because we're just going to proxy it. So layout fragment, and we're going to say this has a var text range, which returns a text range, which is just the text element's text range. Oh, you know what? We want this to be a let text element. And we have this null text storage protocol, which I also don't know if this is really going to be useful or if I can even make these null text locations correct. But well, we're gonna do it anyway. So I should probably make these all in the same order everywhere. It doesn't really matter, right? But the null text storage, whatever text element gets passed in, it always returns an empty NS attributed string. Oh, and now we call configure rendering surface. So what if we just in there, we should be able to print the attributed string that we're about to render right in here. So if we say layout fragment dot text element dot attributed string, and we'll just print this, and hopefully we get the strings. We don't. Oh, well, we'll figure this out. But not here, because the actual place we want to do this is inside the layout fragment. So let's first start by printing layout. Whoops. And we will print the text range. Which of course is totally unreadable. Oh, I hate this. This is just so annoying. And so we're gonna have to do the same thing, right? So we'll should write some helper methods that like print a text range in a string. All right, well, whatever. So the layout fragment goes all the way back. So we have to get the string first, which is going to be the text element text storage as attributed string text storage. Dot the string. All of these names are not great. We'll have to fix them later. I'll also drink some water. And let the start be the text range dot start. Take text range dot start. We also have on the text element the attributed string. Or are we not? Oh, we're just not setting we're not setting text storage. It's okay. We don't have to debug any of this. So we'll do the text. Oh, we're not. So this is just text element dot attributed string. What's happening is in the place that we create the text element, we need to be passing in the text storage and the text range. So we'll pass in self and the text range. Oh, look at that. Foo, and then those are the attributes. It's empty of attributes. Even you can see the new line there. All right, we're on our way. So now we're back in layout. Now we're back into, oh, not that. I mean to open that. Let's quit it. Now we are back inside. Right, perfect. So what we need to do is we need to create the frame setter. We need to create it with the attributed CF attributed string, which is the same thing as an NS as an NS attributed string. So where were we? CT frame setter here. CT frame setter create. So let's make the frame setter. So we let f equals CT frame setter create with attributed string. We pass it the attributed string of the text element. Of course, we have to import core text. We say, now we have the frame setter, so we have to check if it's nil. If f equals nil, it's like, it's unclear to me, like, okay, this is an error condition. Where do we want to throw the error? For now, let's just do this. Nil CT frame setter. Set it. Frame setter is lowercase. Nil CT frame setter, and then what we're going to say is look at that thing. All right. Oh, but you know what? Oh, can it be? Oh, this is weird. How is this wrapped, right? Because this doesn't return an optional. In Objective-C, it just returns a pointer, presumably. A CT frame setter ref. Ah, maybe. Wonder how you check. Well, you know what? This is the type of thing that is probably good to ask ChatGPT. So, how do you check? In Swift, how do you check to see if this function returns null, given that the return type is non-optional, is a non-optional CT frame setter. Oh, you weren't confused. You're now confused. No, you're wrong. This previous answer is you're confused. Let's try this in a new. Let's try this in a new window a new chat to see if it has any. Oh, this is. I wonder if that's correct. Let's try that again with GPT-4. No, that just seems incorrect. Returns. I think we'll have to Google. Check for null in Swift. All right. I trust this guy. He doesn't check for null. Hmm. It's a great question. I to myself, it's a great question. That's so silly. Well, who knows? Um, we'll add a to do and just not check, right? So it says to do docs say f can be null, but this returns a CT frame setter, not a CT frame setter, question mark. What happens if this returns null? Yeah, we'll have to look that up later. Right. But regardless, we create a frame setter and then we create a frame. To create the frame, we need the frame setter. We need the range of the frame in the string, which is going to be the entire string. We need a rectangle with which we can, a path, not a rect, with which we can, we're drawing in. So for us, that's going to be some sort of rectangle. Shape of the frame. Okay, additional attributes. I don't know what additional attributes you might pass in. And then the last thing is CF range is probably bridged to some sort of CF range toll-free bridge to anything? I'm not sure. Let's see. Is CF range bridged to NS range? Huh? Okay, well, seems not to be toll-free bridged, so we'll have to make that CF range ourself. Okay. So, right, what we need to do is we need to, oh, you know what? Right, well, so CF range takes CF index. What is a CF index? Which is an int. Oh, we can do this. Okay, because what I think we can do is get a range of the whole string and then just make a CF range because we're working with an attributed string at this point. And you know what? Given that this is a lookup each time, probably shouldn't be. We should probably just make it with the string, but let's just do this. And then we can say, make it with S, and then we can CT frame setter create frame. The frame setter is going to be F. The string range is going to be the range of the strings. So let's let range is equal to, I wonder if we have S dot range. We just have to do CT range, CF range. Location is 0. The length is S dot length. That's range. Dictionary is going to be nil, and the last thing we need is a CF path. And we don't have that information right now. We need text container, probably, which we don't have. We need information in the we need information layout fragment about essentially the width and height of the thing we're drawing into. But you know what? What we're going to do right now is make just an infinitely large one. Yeah, because we're not going to have anything that's going to overfill lines anyway. So we'll make a CG path from a rect with the transformer. There are other transforms optional, so we can even just leave it out. Cool. So the rect is just going to be CG rect. the origin is 0 and the size is CG size of infinity and infinity. We'll see if this doesn't totally mess up things. What is this? We have one too many. Oh, we have to have the transform this now. CG float time infinity. That'd be better. Cool. All right. So what does this return? This returns a frame. I kind of want to call the frame F. There's too many words. All right. And we'll pass in the frame setter. All right. So the frame. And let's look at CT frame. What does this have? None of these pages are interesting. They seem to have different, this link is to a different thing. Multiple lines of text. Frame object. So you can draw a frame, or you can get the lines from the frame. Let's, for now, just draw the frame. I think that's what we want to do. Just want to draw the frame. We're probably going to draw all three right on top of each other, but it will be better than nothing. So for now, what we'll do is we'll say, let frame, see a CT frame, question mark, and it's actually going to be a var. And the presence of frame kind of tells us whether we've laid out this, this thing. And so we'll say frame, just do that. So now we've created the frame, and the other thing we're going to have is we're going to have a draw in context. So if we look at the fragment, it has a draw in context method, draw at point in context. Okay, that's what we're going to have. So we'll have a draw at point in context function. We'll say let frame equals guard let frame else return. So now we know we have a frame. And what we can do is we can, we'll translate by point, and then we will call the underlying thing. So there's CT frame draw in the CG context. So context dot, how do we save gstate? Context dot restore gstate. And then we will context dot translate by point dot x and point dot y. And then we will call CT draw frame draw, and the frame in the context. So now, in theory, we have a thing that can draw itself after we lay it out. Everything's going to be wrong. We got one other thing that we want to do in here is we want to say this is flipped. Cocoa, and in fact, we're probably also going to, this is it's so silly. So Cocoa views have their origin down here. AppKit views, iOS views actually have their origin down here. Core graphics, the thing you use to draw, has its origin down here. But in general, at least the normal text views, you can have a Cocoa view that's flipped that has its origin up here. And we want to say that this is flipped because all text views in an AppKit are flipped, and we want to, play the same way and just like expect that things are flipped. But what that means is when we go to the layout fragment, we will also have to flip in addition to moving this down by point, we're also going to have to flip the the thing, and I think there's a context.text matrix. Yeah. Oh, this is cool. I didn't know you could do this. So we can just say is the point, and then context.text matrix equals CG affine transform. And we're just gonna scale it. And we scale x by 1 and we scale y by -1. And then I guess we have to do the actual drawing. So that is in text view plus layout. And what we're going to have is, okay, so we do layer dot sublayers equals nil to remove the sublayers. And then here we'll make a layer. And what we want to make is a non-animating layer. CA layers have animations by default. They'll interpolate between their various things. For now, I just want to like not animate anything. How do you do that? No, I actually have this code elsewhere. So we're just going to use that. Default action, you return NS null, which is yet another type of null. So we have a non-animating layer. And then we're going to want a text layer that knows how to draw itself. So whatever, we'll just say text layer, which is a non-animating layer. Create it. This is going to have a layout fragment. And draw in the context, and we'll have a layout fragment. And what we'll do is we'll say layout fragment draw at 0 in the context. We have to add an initializer here. So text layer is text layer. No, this is a layout fragment. Do self.layout fragment equals layout fragment. And we have to add the init with coder. And we'll just leave that alone. So super.init. You know what we have to do? We also have to add init with layer. Because this is used for animation, which I don't need, but we're going to do it anyway. Yeah, you want to have this. So we'll say other equals layer as, and it's always going to be us, a text layer. And then we say self dot layout fragment equals other dot layout fragment, and then we do super.init. Now, I wouldn't be surprised if this actually doesn't get called. So let's put that there to see if it doesn't. We may have to tell it. And then the other thing is, all right, so here's what we're going to do. Text layer, which takes a layout fragment, which we now have. And then we're going to want to like give this an origin, like move it somewhere. But for now, we're just going to draw everything on top of each fragment on top of the next fragment. So let's do that. So we're going to say, I'm going to put the anchor point equals 0 because that kind of makes the most sense to me. We also don't have bounds. We should like to do set bounds to set the size of the layer, but I haven't saved that information anywhere. We're gonna have to save that on layout fragment eventually. And so in this case, we are just going to, and it's okay because for I think core animation layers by default can draw outside their bounds, I think, but we'll figure that out pretty quick. And what we're going to do here is we're going to just say L dot set the frame. No, we can't do that. We just have to set the position to put it somewhere. And the position will be 0. So this is positioned in the super layer. So we're going to draw everything like right in the upper left corner. Hopefully, if we do this well. And then we do L dot or layer dot add sublayer. Maybe this will work. I'm sure it will not. I'm sure it will crash or not build or something. Oh, that's weird. I don't know why this would happen. Okay, that's better. Oh, that's weird. I would have definitely expected us to have a layer. Why might we not have a layer yet? Well, let's print this first. Print layer. I guess we definitely don't have a layer here, right? And let's just print, let's see if we have a layer anywhere. I'm sure we don't. Do this here, we'll just print 5, layer. We will rerun the program, and we've commented that out. Now this, we're just going to comment out for now. Oh, the first time through, it's nil. The second time through, it is there. So we do have the layer at that point. All right, I think we're going to do a little bit more like what I did in this TextKit 2 playground, which is, I believe, is opaque false by default? May want to put that in. No, none of this, right? So I have these different layers that contain each one. We have this thing. All right, so what are we doing? Override func layout in the text view we call super.layout, which I should probably be doing. And we just return if we don't have the layer. All right, so that's what we're going to do. Let's also check is opaque before we forget. Is opaque on an NS view. What does it return by default? Okay, so we want to make, you know what, we're going to move this flipped. So we'll say override var is flipped and override var is opaque. And we'll say that's true. Let's get rid of all those prints also. So this should hopefully not crash. Nothing will happen. Cool. And then let's go to the text view. Put these in here. This seems like the right place for them. And we have update layer. Because we're opaque, we should probably do, first of all, let's print C, make sure that whenever update layer is called, we have a layer. We do. Okay, that's cool. So at this point, we can just, I guess it doesn't matter, right? So here, what we're going to do is we're going to pick a background color to make it be opaque layer. And we'll do that by setting the background color on the layer to be NS color dot background text background color dot EG color. So now it is opaque, so we're not lying to the system, which is good. And now what we need to do is let's add the, we'll add a layer that will be the parent layer of our text. What do I call it? Did I call it text? Yeah, text layer. That's good enough. All right, so it's a CA layer, and it is a non-animating layer. And then I have to find out, so it's layout, viewport, or just layout rather. And I'm doing, right, if it doesn't have a super layer, then add it. So we can do that in here. So if text layer dot super layer equals nil, and what we're also going to do is, or maybe should this all go in layout sublayers rather than in layout? Let's see. Do they even have layout sublayers? Oh yeah, let's maybe do that because I'm not actually putting anything. So let's try this. What if it was? Hmm. So I believe we are the delegate of our layer. So maybe if I just implement, maybe it's just not implemented by default on UI view, but if we do layout sublayer, so let's see, CA layer delegate. Yeah, oh, NS view by default does not conform, is not its own layer's delegate. Is that really the case? Let's see. Let's see. If we were to say, first we're going to have to do guard let layer equals layer else return. We actually don't need this equals layer. And then let's print layer.delegate. And we are its delegate. And so the question is, are these all optional? They're all optional, I think. Yeah, it's optional. That's why. Oh, but this is so weird because it looks like that NSView doesn't conform, but we are in fact our layer's delegate. So who knows? But I think if we just do func layout sublayers of layer, and let's just print over there. Oh, I guess let's do that. Ah, if we were to do this, does that change the fact that it runs? No. If we say that we are a CA layer delegate, does that make it run? If in update layer, we do layer dot delegate equals self, and if we do that without this, without build, yeah, it won't. So you know what? We're going to do this in layout. We're going to do it in layout. We're going to lay out our sublayers because otherwise it just seems a little wrong. All right, so we're here, and if the text layer super layer is nil, then we're just going to say text layer dot. We're going to do all our set. So this is the anchor point is going to be 0. The text layers bounds are going to be equal to layers bounds. And then layer.add sublayers of layer, or text layer. So we add the text layer. Then we call layout viewport. All right, at this point, we always have a text layer, so it doesn't matter about whether or not layer is defined. So this is a way to sidestep that, and it's also an architecture that I'm going to want eventually. And so we'll just say text layer dot add sublayer. All right, nothing shows up. Let's debug and see what we've got. The scroll view here is a text view. All right, so we have a backing layer. And it has one non-animating layer, and it has 3 text layers. So we are adding them, which is cool. You know what? Draw never got called, which I was kind of expecting might be the case. I wonder, just testing our understanding of layers, is it possible draw will get called if we just set the bounds of the layer to some arbitrary size? So this would be, oh, this is the wrong thing, that's why. So what if we were to say set the bounds to be, or the size, and just bounds dot size, we'll do it this way, is equal to CG size of 100 by 100 arbitrarily. And draw still not called. So, and just to make sure, what if we just set the bounds? What is it? The size is CG size. This I think will also not cause it to draw. Nothing has gotten printed, but we do l dot set needs display. It still doesn't do it. So what are we doing wrong here? Let's open up the text layer. What if we were to put, I don't understand how this would make a difference, but if we were to say, let's actually keep the bounds in just, you know what, even before we do that, let's just do l dot border color equals cg color dot red, or ns color dot red dot cg color, and l dot border width equals 2. And so hopefully we can at least see them all kind of, yeah, they all overlap right there. So if after this we say set needs display, I really would think that draw would get called at that point. Oh, it did this time. So why when I did set needs display over here, oh, it did get called. Wait a second. It doesn't get called there. Maybe it is, I think it was setting the bounds, did it? Oh, it has to have bounds, and it has to I wonder if it's because the bounds are getting set. Like, what if we did this and then moved set needs display back in here? Yeah, it looks like we have to have bounds of some sort. It's kind of annoying. And look at that. It's pretty, can't even tell what that is. Well, let's delete some of this stuff. So it's at the bottom of the rectangle. It's actually, we could see it if we added the border back. You can can see it's rendering at the bottom, which means not only do we have to flip, or in the flipping we're not doing enough, we also have to translate it to the top. So we'll have to do that. It's hard to see because it's not clear what it's drawing anyway. But it's the case that it's low resolution. Here's the thing we can, and we'll have to tell the layer to have its content scale to be like, to use the retina display basically. We can do that later. For now, let's go to the place where we create the text storage, and let's just say foo, so I'm only gonna have one line. Should only see one drawdown there. And what's going on? I also would not have expected it to need to redraw every time I move. We resize the. Oh, I know why. It's because we're not saving we're not caching the layer. That's fine. That we'll fix later. I can't even kind of make out what's going on there. Oh, let's play around. Which is to say, what if we don't do the transform? We don't even see it at all. So the only thing that's weird is I would have expected that it would not be drawing all on top. It looks like it's drawing all on top, or I don't even see any letter form there. It makes sense. It's like maybe there's an O there. Who knows? I guess that's the answer. So what else can we set on the context? Context translate by, let's just do -50 or by 50 and 50 and see where we get. I have to do -50. It didn't move, which is a little disconcerting. Well, all right. Well, what if we comment everything out, just draw it? We don't see it. Change the text position, still don't see it. So it seems like the important thing, let's ignore the position right now, is this scale. Now, what if we translate before we scale it? I don't think this will make a difference, but okay, it does not. And that didn't happen. I doubt this will happen. You know what? I bet this is not translating the graphic stuff. Can we translate it by 50 and 50? Let's see what happens if we do that. Nope. What if we context.text matrix equals CG affine transform with the translation of 50 and 50? What if we just have it inverted? Is there an inverted? Nope. All right, so we'll just do CG affine transform translation of 50 and 50 and then scaled by 1 and -1. Do we maybe get anything? My goodness, we get the same thing. All right. Well, maybe we'll ask ChatGPT. See what it says. I have the following code. Oh, let's get that out of there. I have the following code. And I draw in the context. It seems I draw the CT frame in the context. It seems like, what does it seem like? All the It looks like multiple characters might be drawn on top of each other, all in the lower left-hand corner of the CA layer that the context belongs to. Any idea what's going on? It's pretty close to what we're doing. Yes, this is probably, this is the right thing. So we need to know the bounds of the layer. Translate by that. Okay. Oh, can you get the bounds from a context? Bounding box, bounding box of path. Bounding box of clipped path. Let's see. Is there a size? How do I get the bounds? Can I get the bounds directly from a CG context? Right. I think what we have to do is we have to start adding things to layout fragment. So like the bounds of the thing, and then we're going to use those bounds to the bounds of the thing we're going to render, the bounds of the layout fragment, and then we're going to use those bounds to make the size, make the layer. So let's see how we might do that. So first of all, let's say that this thing has var bounds, which is a CG rect, and default has bound 0. And then we have to figure out how to get the, how do I get the bounds of a CT frame? Is that the way to do it? It feels like CT frame. So that was CT frame get path. I wonder if there is okay, get string range, visible string range, get path attributes. Okay, looks like get path is it, and then we just get the bounding box of the of the path. Okay, so this is actually a derived thing, right? So it's var bounding or var bounds is CG rect and guard let frame else return 0. And then here we ask the frame for its bounds, which is to say of the frame, and then get the bounding box, yeah. Okay, so now we have the bounds, which means in, now let's move this over here, layout fragment, and then text view layout. Now that we have the bounds, what we can do is the bounds are equal to, and you know what? We can set all of this, I think, when we make the text layer. Which kind of makes sense, right? So we do L dot anchor point, or anchor point equals 0. Bounds is equal to layout fragment dot bounds. And I don't know, let's see what happens. Oh. Oh, that is a bogus layer size. Is this, are we getting to the point where it's because I'm passing in infinity as the path? Yeah, maybe it's time to have a text container. Or actually, maybe maybe we should look at core text. So it's Marcin, core text, Marcin, K R Y K R C Y A N O W S K I. He was the guy whose blog posts we were reading. So he just creates it. This is creating a line. This is even before he's doing frame setter. So let's open all of these. No, not that useful. Maybe this one. Here we go. Create name with blah blah. Create frame makes a CG path with the bounds of the view. Okay, we don't have that in here, but let's just hard code it into something like 200 and 200. Just to say, let bounds equals CG rect of origin is 0, size is 200 by 200, which is something that's a little bit more reasonable. I think will definitely fit. And let's see if we get 200 by 200. Oh, look at that. It painted. That's cool. And I think what we were seeing before was, in fact, the F, the O, and the O on top of each other. I wonder if I just go back to infinity. So I had CG float dot infinity, CG float dot infinity. Yes. Okay, that doesn't draw at all. That's because I'm making the layer that size. What if we make the width 200 and the height infinity? Right, so this is going to be a question that we'll have to figure out, which is, the way you want to do this is have some equivalent to the NS text container. And for the most part, uh, when you draw with an NS text container, um, the width ends up being the width ends up being the width of your view, assuming what you want to do is wrap lines, and then the height ends up being, oh, do you make the height 0? Let's see what I did with the text container over here. Make an NS text container. We set its height to be 0. What if we set the height to be 0? Now, presumably, the issue is the bounding box still. So, this may be wrong, this frame get path. Path is create the frame. That's not what we want. We actually want what got rendered, not that we want the size of what got rendered, not the size of the path. So what do we have here? Do we have anything? No? How about any other paths? Get line origins. Copies a range of origins for a frame. That doesn't seem right. Well, let's look at how many paths. Oh, what is this? No, this is frame width. Okay. Let's look for width. Where do these attributes come from? Get frame attributes. That's going to be interesting. All right, let's get frame attributes instead of getting, just in here, we'll do print x for a for attributes, I guess, and then ct get frame attributes of the frame. Let's see what we get. Nothing. Great. Okay, so we created without any attributes. All right, now another place to look, which is this same guy has a video that was showing up I watched before, in which he goes into a little more detail. So we'll skip this. Oh, I forgot about perfect pixel drawing. We'll have to do some rounding, but that's for later. Size that fits. This might be it. CT frame get line typographic bounds. We may have to do this on a line by line basis, I wonder. Let's go back a little bit to where he's doing the frame setter stuff. Yeah, that's what we got. Okay, this is too far back. And we just get the lines. Maybe we need to get the lines rather than doing rather than just trying to get this out of the frame. I think that's probably the case. Well, we'll get the lines. We'll leave the drawing with the frame for now. but we'll do the same thing, right, where it's going to be for our line is CT line, array of CT lines. And what we'll do when we go to layout, after we've set the frame, let's also just get the lines, CT frame get lines. And what do we have here? So from the frame, and then we have to do as CT, an array of CT lines. Is that it? I think that might have been what he was doing. He's drawing each of the lines. Yes. Does that frame get lines always return? Or if there's no frame and array, okay, so we don't have to check for nil, which is cool. We'll just do this, let frame, and then frame self dot frame equals frame. And then let's just print out lines. See, we got a line, which only have one. Oh. Oh, I wonder why. I would have expected to have a line. Oh, it's because the height is 0. Now we have a line. The line has some runs. Okay, cool. And then if we map the lines to the bound thing, I think CT line bounds. Okay, typographic bounds. Oh no, that's not quite it. Is it? Get bounds with options. Okay, that looks kind of interesting. Dollars, what are the options that we can have? Use glyph path bounds. No, I think, well, let's do the typographic bounds. People, I don't know. Don't know about any of these. I don't know what optical bounds are. This is kind of interesting. Pretty interesting. Let's try it with nothing. Kind of convert. Treating a forced downcast to CT line is optional. Let's try it. Let's Google this. Treating a forced downcast to C. Even better. What does this error mean? Oh. All right. Whoops. Sorry. Here's the error. But I didn't mean to. What if I do? Oh, I see. Yeah, it's probably because. Yep, there we go. So self dot lines equals lines. It's because the type of self dot lines is optional, and so it was. Yeah, I kind of understand that. Okay, so let's see what getting the bounds are. Well, that's pretty interesting. So let's look at Also, first of all, is that what he was calling in his code? Get so he gets the lines, gets the line origins. He just draws them because he doesn't need to know what the bounds are. He's just increasing by the origins. Okay, this is all for kind of drawing not in a layer. He's drawing directly into the view. Also kind of doesn't matter because let's see what he's doing here. Get the line origins. CT line get typographic bounds. Is that what? Oh no, we're calling okay. Get typographic bounds, which is different. Oh, and then he's doing this line spacing thing. Okay, so let's look at the difference between get typographic bounds and get bounds with options. All right, so the typographic bounds are these three different things. It's also Quartet. There is an icon a diagram that that we would like to see that just shows you all of the different possible, all the different names for all the different. No, it didn't help us, did it? All the different names of all the different attributes of, it's like what is ascending, the ascent, what is the what is the leading, things like that. So this is about cortex. This is not the best place to do it. Let's do in here. Not that. This one. I think we'll probably see. Yeah, here we are. No, none of these are what we want. There must be some other. No, those are right. No, it might be in here. Typographical concepts. Here we go. This is what we're looking at. All right, so descent. Oh, but that's just a glyph metric. Love to see more than just the oops, is there anything else? Well, I know what leading is. Leading is the thing that comes, leading is line spacing, I think. So leading is going to be here. Okay, so descent, ascent, and leading. Occurs to me that this doesn't give you the width of the line. It does give you its height. If you were to take all these and add them up, you get the height. But let's see. I also am getting tired. I'm going to have to stop soon. Do want to get the text showing up. But what was the other one? It was CT line bounds. bounds for a line. And what is the description of this? Calculates the typographic bounds of. Maybe the typographic bounds is just the various parts of line height. The bounds of a line is specified by the options such as. All right, well, let's go back to the core text. Docs and see if, oh, come on. Here we are. Laying out a paragraph. Do we have bounds in here? No, this is not that. No. You know what? This is a good thing to ask ChatGPT. Does this also return something? Oh, it returns the width. Oh, Blarg. Can't believe I missed that. Returns a CG rect that includes the bound space. Okay. So then looking at the just, the other question is what can we okay, so we can exclude the leading, nor cross stream shifts the positioning. I don't know why I want to exclude the shifts. The leading would affect the height. I understand why you do that. Additional space based on common glyph sequences for various languages. Don't really know the difference between that. Use hanging punctuation. Oh, that's cool. Interesting. So I guess it feels like you'd have to render this differently. It's like if you, or I guess maybe there are other things that CT line bound options are passed into. Feels like I don't. It's cool. The idea the hanging punctuations like move the quote. Like if you have a quotation mark that starts your line, move it into the gutter. But just all we're doing is asking for the bounds of the line. At some point I need to learn like what are these various things, but we don't have to now because I think we'll just use this, right? So we're going to have the bounds, and this is just going to be the typographic bounds. So we're going to say bounds, or let, we need all of these, right? So the ascent, the descent, and the leading. Spell it. This is a CG float. And let's initialize them all to 0. I don't know that you have to. Yeah, it's better to do that probably. And then we say let, and this is going to be the width, equals CT line get typographic bounds. And then we'll do we have to do this per line. Well, let's just do it. All right, so, and we're not going to do it in here. We're just going to ignore this for now. So we have the lines. And then for line in lines, look at the line, the address of the ascent, the address of the descent, address of the leading, And then for each line, we are going to print, make a CG rect bounds equals CG rect of ascent for the origin is 0, and the size is CG size, where the width is the width and the height is the ascent plus descent plus leading. And then we'll print the bounds, and that will give us some interesting stuff. Cool. And presumably, if we were to add them all up, we could get the, we'd have to add up all the heights and take the maximum of all the widths, perhaps, and that gives us the bounds. All right, so let's do that. So we're going to say the bounds starts at 0. We get the lines, and then to get the bounds, we will actually say is let var height is a CG float, var width is a CG float. Both start at 0. And then what we'll do is we'll say width equals max. Oh, this is, we'll just have to call this W. Width equals max of width in W. And height plus equals ascent plus descent plus leading. I'll put this there. And then after this is all said and done, we'll do self.bounds is equal to CG rect, the origin 0, and the size of CG size of width is width, and height is height. And then we will print the bounds and see if we get the bounds for the whole thing. Ooh, that's not what I was expecting. I was not expecting it to be. Oh, I see. It's because we have bounds here. Oh, that was glad I caught that. Well, that's also not what I was expecting. What if we print? Oh, oh, that's so gross. We're like, I'm shadowing it in both directions, and so it's now 0 because we're not rendering anything, right? So if we actually do, we'll say the just call this container for now, and I bet we can say infinity and infinity for now, and this will work. And then we can, let's print width and height. Oh, why are you 0? What is going on? How about we print in here? I bet we're not having, oh, you know what? I bet infinities doesn't work. Let's go back to 200 by 200. And I bet now we'll get a line. Just want one line, come on. We're getting lines before. What if we, oh, it's because we're, oh my gosh. So let's go, we'll go back to infinity and see if that, if this works. There we go. That looks promising. That's pretty cool, right? So now, we can print bounds just to make sure, but I'm pretty sure this will be the width. Okay, so width is 16 and height is 12. Yeah, I guess the string foo is longer than its height, so that seems right. So at this point, we now have the bounds. Don't have to print this. We can clean all of this up later. And in the place where we do layout, so text view layout, we're preparing this. And also let's look at the constructor for text layer. That's actually where we can do this. Oh, we're doing this. We're setting the bounds. And it's too small. Oh, is this because of the infinity thing? No, it is not. Oh, and I don't remember how we fixed that. That's freaking gnarly. Let's print bounds here. That is correct. It is drawing. Is it something in the translation? Oh, well, we know this is not right? Because what it was looking at, I think ChatGPT gave us this, which is all we're going to do is a text matrix, and then we translate, and we're going to ignore point for now. This is kind of not right. We're not quite right. Let's do this, right? And really what we're going to do is we're going to say text matrix is CG find transform translation by x is 0 and y is bounds dot height, size dot height, dot scale by 1 and -1. And let's see if we get a drawing. Oh, we do not. What if we just set this to be 200 by 200? I lost the audio there for a second while I switch my headphones. What if we set this to be 0, 0, 200, 200, just, anything to get some text showing up. And we do get it. So why did we not get it? Okay, here's what we're going to do. We are also going to set a border. Border color equals, I don't know, purple, CG color, UNS color dot purple dot CG color, and border width equals 1. So let's see what it looks like. All right, now what if we set the bounds to be layout fragment dot bounds? Run that again. You know what? You know what it is? You know what I think it is? I think the context is too small. Like, what if we just said bounds dot width plus equals 1, bounds dot height plus equals 1, and keep bumping that up? This probably won't work because, so we have to say bounds dot size dot width and bounds dot size dot height, and I bet there's going to be a place that we bump this up to. We'll do 5, where it'll just show up. And there's some amount of, it's like obviously there's some amount because once we get to 200 by 200 it works. This seems a little, we're transforming it by bounds dot height. That's interesting. All right, what is bounds? And is it possible we're translating it in the wrong direction? Like, it was the case that when we did bounds of 200, we saw it. Interesting. So this is, it's pretty low down. I bet if we did height of, like if we do height of 500, it's still at the bottom of that, or is it? No, it's in the middle. That's the problem. All right. So what is it we need? Why is it getting rendered down there? Oh, because it's getting rendered at the bottom of 200. What if we say the height is 0? Presumably it wouldn't get rendered at all. Here's a question. When using CT frame setter create frame, is it possible to say that, like, okay, if we did the width of 200 and the height of, I mean, this won't work, right? I don't think this will work. I think we'll get no lines. Oh, oh no. Well, what's interesting there is we got all of them, but the foo was overlapped, right? And what if we then printed bounds in both cases, right? Oh, we are printing bounds. All right. So now it's just so that is foo. We couldn't tell her that's just foo. The problem now is with the infinite height, they all overlap. It's possible to specify and setting the CG path, setting CG using a rectangular CG path that the height is infinite. So I did this, or something very close to this. When I set an infinite height, all the letters are drawn, right? Set an infinite height and a width of 200. Let's just say we do this. When I do this, all of the letters get drawn on top of each other, right? And then call CT frame draw. If height is 200, 500, the letters, if height is a number, is, let's say, non-infinite, the numbers are split out, or the numbers are, or the letters are drawn correctly. Do you know why? Oh, we could use max float, right? Maybe greatest finite magnitude, CG float dot greatest finite number. Yeah, that maybe gets us. No, it doesn't. And just to confirm, if this is 200, everything works great. No, if this is 200, it's drawn at 200 down. And if it's infinity, it's drawn in the right position. Oh, this is annoying. Annoying as heck. Let's actually, what happens if we don't translate, right? So the width is 200, the height's infinity. And let's just say the bounds are going to be 500 by 500, so it's easy to see. And it's just, oh, it's presumably drawn at the infinite place or something. Let's just do the transform, right? Content dot text matrix equals CG affine transform translation or scale x 1, y is -1. Oh, sorry, this is context. And it is indeed at the bottom once we flip it. It's kind of weird because, like, if it was at the bottom when we flip it, wouldn't it be at the top? Oh, fudge. I find this stuff very confusing. Now, if we do CG float dot greatest finite magnitude, presumably it's not on the screen, it doesn't show up at all. And just if we were to say this, we still don't see it, which makes sense to me. And the question is then if we go to like 200 by 200 or something, what do we see? Okay, it's down here and upside down. And then when we flip it, oh, whoops, it is, where are you? There it is right side up and flipped. I don't know that I would have expected that. What if we only translate? Translate by 0 and bounds dot height. This is going to push it down 200 more, I think. Oh, I would not have expected this. Doesn't move it at all. And that goes back to what ChatGPT was telling us, which is just translate the context. They're not futzing with the text matrix at all. Okay, let's try that. So if we do context, so first of all, we draw with nothing, and it's there. Translate by 0 and bounds dot height, and this is going to push it down, I think. It does not. And if we were to do context dot scale by 1 and -1, and then it's gone. And the first thing they did context dot text matrix equals identity. If this is gone, it's still that, right? It still renders the same way. And now if we scale, does it do something different? Yeah, no, I would have expected, I think that doesn't work. I think ChatGPT is just wrong here, right? But if we do CG affine transform dot or scaled by 1 and -1, it flips it. My goodness. It flips it, but doesn't translate it by 0 and the height, bounds dot height. And it doesn't move. Now, what if we were to say context dot translate by 0 and bounds dot height? So we're doing the flip for the text matrix and everything else in the. Wow, goodness gracious me. I think this is enough for today. I will have to stop. and I'll pick this up some other time. So if anybody ever watches this, thank you for watching. I hope you found it enjoyable.